In this video we're going to talk about the saturation process, and let's just remember that whenever we have a liquid that is at the saturation point, well, that is called a saturated liquid. When we have a gas that is in the saturation point, that's called a saturated gas. But what happens in between? In between, for instance, we have a region which is the saturation process, and there we have a mixture that is liquid and vapor mixture. During this process, the temperature and pressure remains constant. Those are the saturated pressure, the saturated temperature, and you need to input more heat, which will not change the temperature. That's a latent heat, in order to change the phase. We can represent the process in a diagram. And for instance, in these diagrams we will have the properties pressure, volume, and the lines, for instance, in the left one are going to be the constant temperature. In the right one we have temperature, volume, and the lines is constant pressure. In both of them we have a critical point. The critical point is going to be the point where, well, you can go from compressed liquid to superheated vapor without adding more energy. And this region is the compressed liquid region in these diagrams. This region is the superheated region, and in the middle we have the saturated liquid line, saturated vapor line, and in the middle of those lines we have a region where you have saturated liquid vapor region. What you have there is a mixture of both of them, liquid and vapor. The information is also presented in tables. The first table is table A4. This is saturated water, and this is with respect to temperature. So for instance, you will have temperature, and this is the saturation temperature in degrees Celsius, and you will have the saturated pressure where the saturation happens. So for instance, if you have 50 degrees Celsius as a temperature, it will happen in a pressure of 12.35 kilopascals. And then you will have more information, for instance, the specific volume, internal energy, enthalpy, and entropy. We will be seeing each and every of these properties later on, but let's start with the specific volume. Specific volume can be in a range between, in this same case, between these two values. The BF is going to be the specific volume of a saturated liquid, and the Vg is going to be the specific volume of a saturated vapor. So in the saturation process, the range is going to be between Bf and Bg. The same happens with internal energy, enthalpy and entropy. But in internal energy, enthalpy and entropy, it is also reported, for instance, another value. The saturated liquid internal energy is UF, the saturated vapor internal energy is UG, and the difference between these two, UG minus UF, is going to be UFG. You can make this difference, for instance, this value minus this value gives you this value. And the same for the rest, enthalpy and entropy. Table A5 has exactly the same information, but instead of being temperature based, the information is pressure based. You will have the pressure, saturation temperature, and the rest of the information exactly the same. It is very important to know that the enthalpy of vaporization, or energy latent heat of vaporization, is HFG, is the amount of energy you have to give to the system to pass from saturated liquid to saturated vapor. That's the latent heat of vaporization, or called the enthalpy of vaporization, HFG. During the process of saturation, you will have a mixture, and we can define a value which is called the quality, denoted by a letter X, as the mass we have of vapor over the mass that is total. This is, for instance, a ratio, a percentage, if you want to say, of how much vapor is in the mixture. The rest is going to be, for instance, liquid, and this is a value, or has a value, which is from 0 to 1. If the quality is 0, it means that it's saturated liquid. It cannot be less than that. If the value is 1, it means it's saturated vapor, and in the middle it means you have a mixture. This is important because, for instance, if you have a mixture, it's not a saturated liquid, it's not a saturated vapor, the volume, the internal energy, the enthalpy, all of them, all of these properties that are extensive properties, will actually be in a range between BF and BG. If you know the amount of liquid that we have, well, what is going to happen is that with this quality, you can actually say that the volume, a specific volume, for instance, is going to be equal to the volume of the liquid plus X, which is the quality, times the difference between the vapor and the liquid. All of the properties, it happens the same with internal energy, all of the properties during the mixture, you can calculate it like that. In this case, it is reported UFG, which is the difference between UG and UF, right? And the same with enthalpy and whatever. So you can know actually the quality as well by solving for X here. Given the property, you can have the quality as well, not only with the mass. Very, very important in order to get the quality. So we have discussed in this tutorial about the saturation process.